All right, let's talk about the photoelectric effect. If I have a sample of a metal and I hook it up to a battery and I have another metal electrode here, the vacuum in between, if I start cranking up the voltage or potential difference, eventually I can actually get an electron to pop off and move here just by applying a potential difference. And we call this amount of energy the work function, which is the minimum energy required to move an electron from an atom in a metal. And this work function is equal to E, the charge on an electron, times V, the potential difference. You might notice this formula in a slightly different form, E equals QV, which we learned when we were talking about electric fields. All right, moving on to more photoelectric effect type stuff. If I shine light onto a piece of metal and an electron does not come off, it will never come off. I could use 1,000 lights and it would not get an electron off. I could do it for 1,000,000 years and I still would never get an electron to come off. Absolutely will not happen, which was a surprise to them. Because classical physics said sooner or later you'll get an electron to come off, but it's not going to happen here. If I give light with just the right frequency, I might get electrons to start popping off. And if I have light of even greater energy, I would get electrons to come off with an even larger EK. Yeah. We call F0, we call this the threshold frequency. And that's the frequency just to get an electron to pop off. So here's a little experiment set up. Let's pretend that this guy is not here. Let's just pretend it's a wire here. So I've got light comes in. It does have the proper amount of energy. It hits the emitter plate. Electrons pop off, move over here, yes, and hit. Now, when they pop off, this becomes positively charged. This will become negatively charged, and electrons will start to flow. Electrons, because this is positive, will be pulled up. Electrons, because this is negative, will be pushed down, and I start to get current flowing, and I can see it on the ammeter. Another experimental setup here. I've got a variable resistor hooked up to a battery, so I have some potential difference here. So when this voltage is 0 here, light hits it, pops off, flies up. Yes, and maybe it gets this far. Yes, or makes it all the way to the other side. But as I start to increase the potential difference, thereby making this negative and this positive, when the electron now pops off, it doesn't have, it's fighting against something. It's fighting against, does the electron want to move towards this negative plate? No, it does not. So I can make it more difficult to move up. And using this experimental setup, and I know that energy is equal to, from up above, QV or EV, yes, work function. I can start to do some experimental setup, because what's the energy, this photon, what's it doing? It's liberating the electron, and that amount of energy is called the work function. And it's giving that electron some kinetic energy. Yes. And using this setup, using this formula, I can do all sorts of problems. And remember that often here, the work function is going to be equal to E, the charge on an electron, times the potential difference across these plates. And that's it. It's our brief little look at the photoelectric effect.